start copying this down?
Oh,
We're gonna,
That's
these are the study questions for the test. I'm actually looking at the test, writing stuff up so that we get an idea. Maybe I'll write answers in blue. Hopefully we can see. Oh yeah, it's plenty.
Today's the 19th.
Today is the 19th. There's a little bit of glare. I'm gonna cut one of these lights. I think it needs to be this one. Yeah, the other one. Okay. I can get rid of some of the glare. There's still some glare on the board. Actually, it makes the glare worse. That doesn't make any sense. All right, let's go back to where it was. Ha heavens! All right. So domain and range of a function is the first question, and the best part is you'll have a picture of the function on the test itself. Yay! Yeah. You're so mad. Don't be so angry all the time. So let's talk about domain, right? Domain, all the x's that could possibly work in this function. So let's talk about the domain of negative 3x to the fourth. It's just a sketch of it. It's not perfect. What would the domain here be? What x's can I put in there and get something out? It is. It is. It's an infinite domain, and I need you to write it like negative infinity to positive infinity. Okay? Cool. 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 While I'm on domain, let's go ahead and look at the second one. 5x to the fifth. What might the domain be for this one? Can I put in negative 7 billion and get out an answer?
Yes.
Yeah. Can I put in positive 7 billion and get out an answer?
Yes.
Yeah, it's big. It's enormous. But yeah, absolutely. So would that domain be the exact same thing? You betcha. So the domain for both of these is infinite. Sorry about my back. Cool? So let's go red for range. Now, when we talk about range, we talk about it from the bottom up. Okay? So this one, both arrows are pointing down, right? So it starts where?
Yeah. Pretty good.
Does it ever stop going down? This one?
No,
Yeah.
never.
So we start at negative infinity. And where does it stop?
0.
0. Oh my gosh, it actually includes 0, because if I put a 0 in, I get a 0 out, right? So I bracket that, brother. Right? Now we'll look at the range of this guy. Sorry about my back there. We'll look at the range of this guy. Again, this goes down infinitely, and then on the right side goes up infinitely. So the range looks just like the domain.
Wait, why answer you?
See how that arrow is pointing down?
Yeah.
That means it goes down infinitely.
Yeah.
See how this arrow on this right side is pointing up? It goes up infinitely. Never stops. Because we can just keep putting larger and larger values in, get out a larger and larger number. All right. So to make this work, yes, you're looking at the graph. Yes, you're understanding where it starts and where it stops. I'm going to tell you that if you know these, you're going to be good to go. You'll be able to write it just like that. That's how I want you to write it. I took all the multiple choice off. You're going to write the answer on the line.
What do you mean draw?
Too easy. Multiple choice is too easy.
You gonna hype
For
us up
7
saying-
questions, come on, man.
Sir, you gonna hype us up saying it's a multiple choice quiz or a test?
I know, but there were only
whatever.
4 multiple choice.
Still. You
Come on,
gonna hype
man.
us up saying it's a multiple.
You already
choice.
know that the domain for all those functions that I'm going to give you is infinite. So you got
That's
half the answer right there.
So that's like telling your kids you're gonna take them for ice cream and never take them.
Yeah.
Well,
Come on, Cheryl.
them's the breaks, kid.
My mom does that to me too.
Yeah, I saw my mom used to do that.
Everybody pack up. We're going to Disney.
Yeah, who did that?
Then they dropped him off at Valley Forge.
Yeah, I heard that.
Goalie.
You know that? The Douglas. Remember Sierra, sir? Sierra. That you? Jada Sierra.
I don't.
Appreciate it, man.
Same idea.
You look like fresh or something. Sure.
I don't know who that is.
Couldn't graduate.
They,
He's telling me he was going to Disney World.
Fresh Prince of Bel-Air.
Rude. Oh, okay.
That's what he
Yes.
What did they tell you was going?
They said we was going to the mall.
Nah.
And then they dropped me off.
Yeah, I ain't gonna lie, bro. The moment they passed Baltimore, bro.
Now, the moment I seen the direction say we'll get there at 11 and the time was 9, I just knew it was accepting my fate.
But did you know that he was coming?
Okay. So how do I undo a square root? How do you undo the square root? You square it.
Yeah,
square.
Right? So if I need to undo a cube root, I'm going to cube it. Right?
I understand
So-
now.
Now, I just want to, my radical's isolated. The radical that's on your test is isolated. So all we're going to do is undo whatever it says. And by the way, it is a cube root on the test. The numbers are a little different.
Is the test tomorrow?
Yeah.
Okay.
I'm ready for this.
If I get done. So this cube gets rid of this root. If I cube this side, -2 times -2 times -2 is
Eight.
-8. -8. So equals -8. And I just got rid of this radical. So all I have left is x minus 4, right? And I just want to get x by itself. So what do? Just going to
-4.
add that 4 back. Add 4.
So we have x equals -4.
X equals -4. And you have your answer.
Okay.
Okay.
Cool? Cool?
Okay.
Wasn't too bad.
What's wrong? You got a face. I got to make sure your face is okay.
I'm good.
All right. Can't have Sean making a face.
That's your star student.
He needs success.
I'm the star student.
Sure, how's your honors class doing? Are they good?
They're cooked.
Yeah, they're sagging a little,
They're
but
killing it?
they'll be all right. They'll be all right. We had a bunch of breaks in there that we didn't need. Are we caught up? All right, so let's talk about end behavior. End behavior. I may put the multiple choice back in for this one because of the
Yeah.
limit notation.
Question. You didn't like cube the x take -4.
Because it has a cube root around it,
Uh-huh.
to undo it, I cube it.
Oh, okay.
All right? It's the opposite. You're doing the opposite to get rid of it.
Okay.
And if I cube one side, I had to cube the other side. Right? And there's no cube root around this guy, so he just gets cubed. Or, sorry, they just get cubed. Not sure about that gender.
It just gets cute.
What is the end behavior, right? That's the ticket right there. So we know, just look at this guy right here. If we look at the leading term, we know what the end behaviors are going to look like. Okay, so this one's negative and odd, right? Negative with an odd power. So an odd power looks like this, right? But negative makes it go the other way. So it starts high and goes low. So I'll put it up here. X cubed starts low, goes high. Negative x cubed starts high, goes low. So the end behavior here of that function as x approaches negative infinity, whoops, that's a horrible infinity sign. There we go, is negative infinity. The limit as this same function as it approaches infinity is infinity, right? But this guy the limit is turned around. So maybe I will put these guys in there to save you from writing in limit notation.
Thank you, sir.
Am I not a benevolent God?
You're not a god, but you are beloved.
Malevolent.
So it's the other way around. Okay? Does that make sense? So as we go farther and farther to the left with this function, this is going down.
And these are notes.
As we go farther
So
and
we can
farther
get
to
the,
the right.
Are you gonna write
We'll
the
go
x
up.
squared cubed and to the fourth? Like in the
What, a picture?
Yeah, for the things.
That first one has a picture. This one does not. So you have to know, if it's even, both ends are pointing in the same direction. If it's odd, they're pointing in opposite directions.
So if it was a negative, like it's even, it'd go down, but if it's like positive, it'd go up.
Correct. Did you hear what he just said?
So x to the fourth, it would be going
So
down.
this one,
It'd go up.
they going up. Next, this is positive. This is negative.
Okay.
So in limit notation,
So x squared would be the same thing, right?
you betcha.
All right, it looks the same. Got it. Because I thought it looked different.
Nope. The ends look the same. The ends will always look the same. The middle looks different because sometimes there are bumps in there, right?
Mhm.
Like the function they give you has a ton of terms. And we don't care about the bumps. We're only looking at the ends
Only the
on this problem. So for the one that's pointing up, both are pointing up infinitely, and then both will be pointing down infinitely. I just don't feel like writing the whole thing. Cool? Cool. All right. Now we're caught up. Let me move and create number 4 for you.
Whoa!
What happened?
Nothing.
Should we die?
Sure.
Yeah, you said number 4.
I almost did.
Shit.
Ah, one of my favorites.
One of his.
I thought we were over.
How many possible turns. Here's your function.
Excuse me.
How many possible turns? How do you know?
5.
4.
5. Turns is the degree. Sorry.
Possible 0.
I meant to write zeros.
Oh,
Because that would be 5.
okay.
I had zeros in my head and I wrote turns. I'm going to add another one.
Wait, so how would I find turns?
Zeros
0s is 4.
is 5, right? Is the degree.
Okay.
So that answer is 5. I'm going to add one in there. So we'll have 8 questions. But how many, this is the one that Thomas was answering.
How many possible turns?
How many possible, you got me, Thomas, turns. Oh. And that would be 4, which is the degree minus 1.
Why would it be 4?
The degree is 5.
Okay.
It could only possibly turn 4 times.
Okay. So if it's like 6, it'll only go like 5 times.
Correct. Super simple. Yay.
And I have to write 4 degree minus 1 on my test.
Yeah. You don't have to. You can just write 4.
Okay.
I would understand. Okay. Forget it. I'm going to make number 5 this instead of what it says.
Okay.
Okay? And make it even easier. Yes, sir.
So, for number 3, I was just waiting till you on the ask this question.
Yeah.
How come for number 4, you have, in my notes, when there's a positive or a negative, you have 2 graphs, you have 2 parabolas, that's what you call them, a parabola, when it's shaped like a U.
Uh-huh.
Okay, so one shaped like U, and then there's the next one where it goes like this, and then it goes back down, and then it comes up. How come it's not this?
It just has a bump in it.
So,
But aren't the ends pointing in the same direction?
yeah, so the bumps don't
So
matter.
the bumps don't matter. This has a bump.
Yeah.
There's a bump there. It may be flat. There are turns here. It doesn't matter. It doesn't affect the end behavior. It doesn't affect the outside of the function.
So
Because when we're talking about end behavior, we're only talking about where those end arrows are pointing. Whether they're both pointing up, they're both pointing down, they're pointing in opposite directions in a positive manner, starting low and going high, or starting high and going low. So we're only looking at my fingertips.
okay. Will there ever be a time where we look for the bumps? Sir?
Say it again?
Will there ever be a time when we look for the bumps?
We already.
No, because it's a higher level skill. We will look for bumps in calculus if you take calculus, because you need to know those critical numbers. Where that function turns, where the slope of that function is 0, it's a really important number. But in this class, no dice. We don't address it. So forget it.
Yes, sir.
No, it's a good question though. Okay. Oh no. I'm gonna write something. It's gonna be random. Are you on 4 yet, Sean?
Go ahead, do what you got to do.
Okay. Well, I don't want to lose you. I just need to do some synthetic division
For the last one?
for number 6.
Oh, we got 7 questions?
There's 7.
Okay.
This is 5. So number 6, they're going to give you a function and they're going to give you 2 factors. You have to do them both. And tell me which one, if any, is a factor. So 6. I'm going to give you an easier function. This one, the next one's a little bit longer. X to the 4th minus 3x squared plus 2x
Oh, yeah. I got this.
minus 10. And we want to see if x plus 1 or x minus 2 are factors,
Okay.
right? So we have to do them both.
I got a question.
Yeah.
It's about the last question, though.
About this?
The one about, number 4. So, let's say that 3x had a 3x to the 6th power. Are we looking at that then? For the possible
The
terms?
power, yeah.
Okay.
That initial power tells us how many zeros, possible zeros.
Okay.
So we need to set this up. Is there a term missing? I go x to the 4th down to x squared. Uh-oh.
Yes.
I'm missing a term. So we see the x plus 1, so we have to show the opposite inside the box. And then we have 1, 0, because there's no x cubed term. -3, 2, and 10. I don't know if any of these work. I just made this up off the top of my head.
Okay.
So I apologize.
All right.
So drop it. -1, -1, 1, -2, 2, 4, -4, -6. Since we have a remainder, is that a factor?
Nope.
Nope.
So we say it is not.
Not a factor.
Go
I'm going to do the next one by putting a +2 in a box. Excellent. So 2, same thing, 0, -3, 2, and 10. Okay.
Drop the 1.
1, 2, 2, 4, 1, 2, 4, 8. Closer, not even. But not a factor, right?
Mm-hmm. So both of them are factors.
So neither of them are factors. I'm going to tell you one of them will be, at least one of them will be a factor on the test. Okay? Yes. Unless I change it.
Uh-oh.
But that's an easy way to do it, right?
Yep.
Nice and fast. Question.
Yes.
I did the homework.
You're not. But the good thing about it is you can watch this 8 million times.
I don't need number 6. I already got
Right,
it. Back in my head.
right. So the best thing about number 7 is that it's synthetic substitution. They give you the number to put in the box, and they give you the function, and they say, what's the answer? They give you a function, and they say, for this function, has all the terms, by the way, what's the answer using synthetic substitution? So let me use 3x to the, f of x is 3x to the 4th minus 4x squared plus 5x. Ooh, I don't like 5. Oops. I'm supposed to have all my terms because the test does. Third squared minus 8x plus 11. Okay? And they give you a value, f of 5, which is the same thing as just put a 5 in the box. Okay? If I need to remind you, I'll remind you. 3, -4, 5, -8, and 11. This is my answer. 3, 15, 11, 33. No! What have I done to myself? 38. 15, 40 is 190. Oh, gross. 182. Look at what I've done to myself.
182 times 5.
This number 7.
Yeah. All right. So 500 plus 40 plus 10. So 550. 550. So 561. Yours is going to be a lot easier. By the way.
Is it one? Okay, what are we doing again?
5 times 182?
Is 910.
910.
That's what I got.
What did I do wrong? 500. Oh, plus 400. Plus 10. Ah! Thank you for the help there. I'm brain dead. 921.
Oh, we're at
First.
Adding. Woo! I made a mistake.
we're even.
That's
You
it.
going to bed?
The end. What happened?
I'm trying to figure out what's the difference between synthetic division and synthetic substitution.
Division, you get a binomial,
Okay.
x plus or minus something. Substitution, they tell you to put that value in for x. So you're using the actual value in the box. For division, you put the opposite of that value in the box.
Okay.
Any other questions? We did it. I'm so proud of you guys. It's gonna be good. I should give it to you right now while it's fresh in your mind.
Yeah.
Okay, give it to us right now.
Yeah.
I lied. In 15